Hey everybody, let's try a similar dynamics example to the last one with the Atwood's machine, but this time let's kind of spice it up a little bit. Let's say the ramp is at an angle like this. So there's a pulley, a massless pulley, and then there's another block here. And let's say this is smooth. This pulley is massless. Massless pulley, so that means the tension here is the same as the tension here. And smooth, meaning there's no friction here. Okay, so let's do those steps again, the same old steps, right? Step 1, draw the free body diagrams. So for block 1, for block 2, so block 1 is kind of this way, right? And I don't want to see like you draw block 1 like this and then draw the forces. So the forces will be, there's tension from the rope, it has weight, and there's a normal force, normal to the ramp. If there were friction, it would be this way. Okay, so this is the free body diagram for block 1. I don't want to see this, right? Because if you draw it like this, that actually means you decided beforehand that you're going to make coordinates like this, and then you drew it according to the coordinates you picked first. So you should draw the free body diagram first, then you can pick coordinates afterwards, like this. Okay, let's finish free body diagram for block 2. So here's block 2, free of its surroundings. There's the rope, tension, the block has weight, and there we go. We got both free body diagrams. Now let's pick coordinates. And you can pick them like this if you want. Totally fine, nothing wrong with that. For me, I know that block 1 is going this way. So I'm going to pick my coordinate axis that way. Personal preference. And then I know block 2 is going down, so I'm going to pick my coordinate axis this way and even use the same axis. So both blocks are moving in the positive x direction. My personal preference. You could totally pick coordinates like this. There's nothing wrong with that. Okay, so if I pick like this, the issue now is, where's the angle over here? So that's something we need to discuss. So let me define this as some angle theta. So where is that? Here. So if you just look at the picture, right, I kind of drew it. This is the ramp, right? So this is theta right here. But how does that help us here? So imagine, see the dashed horizontal and vertical axes, and then the solid red axes. Imagine taking the dashed horizontal axes and rotating them clockwise by angle theta. Right, so you go from the dashed line clockwise to the red solid line. From the dashed line clockwise to the red solid line. Dashed line, solid line. Dashed line, solid line. See this picture? And now look at this picture. That means for sure this is theta. Right, so remember this trick, this strategy of kind of rotating entire coordinate systems. That'll help with the geometry. So now that we settled that, we can write Newton's second law decomposed. Right, so now this is the x direction. So what's the x component of t? Positive. What's the x component of this? So x is this way. So this is the x component. And notice that's opposite the angle, right? Opposite. Opposite means sine. Okay, what's the x component of this? Nothing. Oh, I wrote this in the wrong place. Over here, plus sine. Okay, the x component of this is nothing. And then that's it. Mass times acceleration. Okay, y direction. I picked y over here, so that's positive. The y component of this is 0, and then the y component of this is negative, and this is y, right? And see how that's adjacent to the angle? So minus, and adjacent means cosine, equals mass times acceleration. Before going any further, I purposely picked my x-axis going this way because now there's no motion at all this way, right, in the y direction, because it's only moving in the x direction. If there's no motion in y, for sure ay is 0. Not always, just because of the way I picked my coordinates. Okay, so I feel like that was clever to pick it like that because I could cross this out. Okay, now block 2, x, so this is positive, and that's negative. Mass times acceleration. And then nothing's happening in y. Okay, so let's say we know both masses. Like we're given the mass of each block. So then, now it's time to figure out what is known and what is unknown. So that means I don't know the tension, I don't know this, I don't know that, I don't know this, I don't know this. So that's that and that and that. 3 unknowns. But we have 3 equations, so no problem. Right, so solve 3 equations, 3 unknowns. I can get that immediately. So that's done. So that just leaves this and that. So you just, let's say, solve one of them for t. Let's say maybe this one. T is, right, and then take that and substitute it right here. Right, so plus equals, and then there's only one unknown, which is ax. So I'll move it on this side. I can factor g out of there, right? Okay, and then just move this in the denominator. So then there is the acceleration of the blocks. It's the magnitude, right? They have different directions. And then you can take this and substitute it right back here to solve for the tension T. And then you have all 3. Okay, I hope that example helped. Let me know if you have questions. We'll see you on the next video.